Hello everyone. Today we'll be presenting on heat pumps, thermodynamics and application by Group 13. Introduction. Heat pumps are energy efficient devices that transfer heat from a lower temperature region to a higher temperature region using external work. They operate on the reverse Carnot cycle or a vapor compression refrigeration cycle and are widely used for heating application in homes, industry, and commercial buildings. Components of a heat pump. Evaporator. Located in the low temperature region, the evaporator absorbs heat from the surrounding air, water, or grounds, causing the refrigerant to evaporate. Compressor. The compressor increases the pressure and the temperature of the refrigerant, requiring work into inputs to compress the refrigerant. Condenser. Located in the high temperature region, the condenser releases heat to the surrounding, causing the refrigerant to condense. Expansion valve. The expansion valve reduces the pressure of the refrigerant, causing it to cool down before entering the evaporator. Heat pump cycle. 1. Evaporation. The refrigerant absorbs heat from the external source, changing from liquid to gas. 2. Compression. The compressor raises the temperature and the pressure of the refrigerant with external work done on the refrigerant. 3. Condensation. The higher pressure refrigerant releases heat into the desired space, condensing into a liquid. 4. Expansion. The refrigerant expands and cools before entering the evaporator. The cycle repeats.
The first law of thermodynamics. 1. Energy conservation. The first law of thermodynamics states that energy cannot be created or destroyed, only transferred or converted from one form to another. 2. Heat transfer. A heat pump absorbs heat from a low temperature source and transfers it to a higher temperature space, requiring external work output. 3. Energy balance. The total energy input equals the total energy output, satisfying the first law of thermodynamics. The working principles of the first law of thermodynamics. Heat extraction. A heat pump extracts heat from a low temperature source, such as air, water, or ground, and transfer it to a higher temperature sink. Refrigerant rule. This process is achieved by working refrigerants, which undergoes phase change and pressure variations. The second law of thermodynamics. 1. Entropy and heat flow. The second law of thermodynamics states that heat naturally flows from a hotter to a colder body, unless external work is applied. It also introduces the concept of entropy, which always increases in a spontaneous process. 2. Work-driven heat transfer. A heat pump reverses the natural direction of heat flow by using external work to move heat from a lower temperature source to a higher temperature space. 3. Efficiency and entropy. The heat pump operates within the constraints of second law by increasing the entropy of the surroundings, even as it reduces the entropy within the system, ensuring compliance with the thermodynamic principles. Heat pump working principles with regards to the second law of thermodynamics. Heat pump uses external work to move heat from a cold source to a hot destination. While heat pumps reverse naturally heat flow, they do not violate the second law of thermodynamics. The total entropy of the universe still increases due to inefficiencies like compressor heat losses. The second law of thermodynamics states that heat flows naturally from hot to cold, increasing entropy. However, reversing this process, moving heat from cold to hot, requires external energy. A heat pump utilizes this principle, using work to transfer heat against its natural direction, enabling efficient heating and cooling.
Types of heat pumps. The air source heat pump. It extracts heat from ambient air, but is less efficient in very cold climates. The ground source heat pump. It extracts heat from the ground or underground water. It's more efficient but costly to install. The water source heat pump. It uses water bodies like lakes or rivers as a heat source. It's highly efficient but location dependent. The absorption heat pump. It uses heat energy instead of electricity. It's typically used in industrial applications. Coefficient of performance of a heat pump. The coefficient of performance of a heat pump is a measure of its efficiency. It's given by the heat delivered to the high temperature region divided by the work input required by the compressor. The ideal Carnot coefficient of performance is given by the temperature of the heatsink divided by the difference between the temperature of the heatsink and temperature of the heat source. Advantages of the heat pump is highly efficient compared to traditional heating system. It makes use of renewable heat sources. It reduces greenhouse gas emission. It is used for both heating and cooling. Disadvantages: it has a high initial cost. Its efficiency is very low in cold climates. It requires regular maintenance. Applications of the heat pump. It is used for home heating and cooling system. It is used in industries to recover heat by capturing excess heat from industrial processes. Heat pumps are used in hot water heating in homes and businesses. Heat pump technology is used in refrigeration and air conditioning systems.